Hello and welcome back. In this video we're going to continue looking at exponential growth. Our introduction was to look at the moon problem and look at some other growth things. In this video we're going to look at some charts and determine whether they're exponential or not. We're also going to review whether they're linear. If they're neither one of these, we're going to say they're neither at this point in time, but later on we might be able to match some other type of growth model like quadratic or those types as well, as to model those functions later on in the class. So if we're looking at a chart of values where we have x and f of x, and we have a common growth pattern of x, that means we start off with something and we increase by a value that's constant. So we're increasing by 1 here on these. We're increasing we can increase by anything we want on that side, but as long as there's a pattern there, we can look at this side over here to tell whether it's exponential or linear. Now linear, just to review, linear growth means that there's a constant increase or decrease. So an example of a linear growth model would be something like, maybe we start at 5 and go up by 2, so it'd be 7, then 9, then 11, and then 13. So this linear one would be going up by 2, so that means our model for that would be 2x, increases by 2, plus 2. Now we would look at our 0 value here to figure out what our initial value here, which is 9, and that would be our intercept. 2x plus 9 would be our linear model here. Okay, now if we had an exponential model, it's a little bit different. So in an exponential model we're looking at not constant growth, but a increase by a factor. So we're still looking to see if these go up by the same amount, -2, -1, 0, 1, and 2. They have to go up by the same amount. Let's move this down for a minute. We're going to do that next. All right, and we're going to look at this factor. So going back to this, we're going to look at whether, so we're still increasing here. Increasing by constant. So we're okay. Over here, what we're going to be doing for exponential, we're looking for a growth factor. Okay, and that could be a multiplication by a factor or a division of a factor. Okay, so for example, we could start off with, if we were doing a multiplication factor here, we could start with the number let's start with 5. And if our factor was 2 to the x like it was before, we could double that and get 10. We could double that and get 20. We could double that and get 40. We could double that and get 80. So this would have a factor of 2, growth factor of 2, because we're doubling each time. Each time we're multiplying by 2 times 2 to get to the next number, times 2 to get to the next number. Up here we're adding 2 each time, but we're multiplying. We could also have a factor that divides. We could multiply by a fraction to divide and get a growth factor of 1/2. If we started with 80 and went down to 5, that is also an exponential problem, but it's going to be exponential decay, which we'll talk about in another video. So I'm going to write down the equation for this, but I'm not going to tell you how I got this. So we have 2 to the x because of that. I'll tell you that. And then this one number that's in front is going to be 20. And you might be able to see where that comes from if you look in your chart. So this is the actual equation for this chart. If I put -2 in here and I raise it to the power of 2 to that power, let's just double check that. Let's just double check that. I have this graphing calculator here ready to go. So if I go 20, let's make sure it's working. Alright, I have 20 times 2 to the -2 power. Whoops. To the -2 power. I should get 5, and I do. If I hit second enter and bring that back and change this to 1, I get 10, which I do. If I second enter again, change this to 0, I get 20. And so forth and so on. Well, let's just make sure I get all of these that I got from that chart. It looks like everything's working. Second enter. This is how we don't have to type the whole thing in again. We just can go back and change. So everything works out there. So this is my equation. So we're looking for a factor if it's an exponential, or we're looking for a constant of increase or decrease. So we could have a -2 on this one too. All right. Now the second part of this is using your e to the x button. So this button here is your power button on your calculator. So we just did that and we evaluated some of these. So I was practicing using my power button there. Now the e to the x button is this one right here. Actually, it's right here. And we have to hit second e to the x. So if we wanted e to the second power, we would type it in our calculator. It would look like this. And it's an approximation. 7.39 to 2 decimal places. Now e is a value that's about 2.71. We could just make sure we have if we want a longer approximation, we just do second e, put a first power in there. So 2.718 is about what e is. And that's what the base of this thing is. It's just e is a number like pi, and e is found by using an equation for compounding interest. You're trying to make it a problem, and that's continuous compounding, which we'll talk about later in this class. So it's right now you just need to know how to find that e to the x button on your calculator, which is right here, and how to use it to figure out the values for e to the second power, e to the third power, e to the -1 power. So e, you should know, is a base that's around 2.718 is about what e is.